All right, well, hello and welcome everyone to our session here today. This session is STP306. It is Evolving Your Security Through Key Growth Stages. Now, my name is Jay Michael, and I'm joined here today with Faisal Farouk. We're both solution architects, and we work with startups on AWS across all of their stages of growth. We also both focus on security in particular. Now, security, it's a really broad topic, and it can be tough for startups to know exactly what kind of practices can have the most impact for their business based on their current level of maturity. And so today, we're going to try to help and clear up that picture a little bit. Now, to kick things off, we're going to briefly talk about the nature of security and why it's particularly challenging for startups. We're going to then present what we'll be using as the stages of growth throughout today's talk. Now, there's a lot of different models out there, and so we came up with one that we think is a nice distilled version that we think should work pretty well for today. Now, for each of those stages, we're then going to get into the characteristics that define that stage, some of the security techniques that you can then consider to implement, and then we'll get down into the actual implementation guidance. Now, as I mentioned before, security is a pretty broad topic, right? But it can also get pretty deep. So we've got an hour here on this session. We're going to talk mostly about organization-level security. So these are the things that you can do to protect your overall operation on AWS, regardless of what workloads that you run. Now, as a quick disclaimer about the topics here today, our goal is to raise awareness of different techniques that you can use to secure your operation on AWS and how they help at the various stages of growth. We're not going to be recommending that you forego implementing any of these techniques from the sole basis that your business is not necessarily at that particular stage of growth. Every business is unique, and it needs to make its own decisions about what techniques you're going to ultimately use and when they make the most sense to implement them. For those who would like to review the holistic security practices on AWS, you can find these in the security pillar of the well-architected framework, which is in that first link, and also in the AWS security reference architecture, which are both linked here. And when you think about what makes working at a startup unique from other types of businesses, it really boils down to having limited time, money, and resources to get your ideas to market and acquire customers. And so you need to have a lot of freedom to experiment with different ideas, test them out with the market, perhaps do some pivoting based off of how well it goes. Now, on the other hand, security is defined as restricting freedom to protect yourself from harm. It includes protecting yourself from internal issues like misconfigurations, accidental deletions, other things that can be tough to recover from, as well as from external issues. And so the techniques that we're going to be discussing today, they're going to help you to be able to balance the security of your environments with that freedom and agility that you need to be able to grow your business. All right, so for today's talk, we're going to be using these 4 key stages here. The first stage is going to be prototyping, and that's where your founding team is building the first version of your product. You then transition into scaling up, where you get that initial product market fit, and you start rapidly acquiring customers. Now, at some point, you may look to target other markets, bring new products online, or introduce broader capabilities. We're going to be referring to that here as scaling out. When enough of those products, markets, and channels are firmly established, you then transition into sustaining so that you can keep going indefinitely with your success. So let's go ahead and jump into that first stage, which is prototyping. Now, startups that are prototyping, they're usually going to be pre-seed or have an angel investor. They consist of their founding team, and they're working to build that first MVP. And at this point, you don't really have any customers, or the ones you do are going to be of that friends and family style variety. So the theme of this particular stage is to establish a security baseline. So we recommend that you have a properly configured AWS account with individual per user level access. You're going to also want some basic logging and monitoring in place. And that way, you know if something undesired is happening, that you can go about actually fixing it. Now, today's session, it's a 300 level session. So we're actually not going to spend a whole lot of time here on the security basics of the prototyping stage. Instead, what I'm going to recommend is that you take a look at this Startup Security Baseline guide that we published earlier this year. It does give you the step-by-step instructions on how to properly secure an AWS account from day one, and it is specifically written for the early stage startups that are in that prototyping phase. And so with that, I'd like to go and move into the meat of today's talk, which is really starting with that scaling up stage. So the startups that are scaling up, they're typically going to have raised that seed or a Series A round, and they'll have launched their product and established some early market fit. Your founding team is grown now into a fuller team of engineers, though everyone is still a generalist and is wearing many hats. You're predominantly going to be focused on learning how your product is operating in production and seeing where the changes are needed to better fit the market and operate at scale. So, theme during this stage is going to be centralization. You're going to be creating multiple AWS accounts for the purpose of environment isolation. And as a result, you're going to need practices like central identity management and logging, periodically reviewing your permissions and rotating credentials, and also some foundational security reporting and monitoring. You're going to also want to start thinking about compliance at this stage if you find it's going to be applicable to your business. So starting with environment isolation, the goal is going to be to have your production resources and your development resources operating in complete isolation from each other, as well as from the other environments that we're going to be recommending shortly. Now, it's not uncommon for a startup that's doing prototyping to just be operating out of a single AWS account. And perhaps they're just doing some isolation of their development and production using VPCs, which is depicted in the picture here. Now, ultimately, this is not scalable, as it does become tougher to manage things like permissions, costs, and service quotas as you grow. And so instead, we actually recommend putting every unique environment into its own AWS account. And so to take a look at what that looks like, transitioning into that multi-account environment, let's do a little bit of a walkthrough here. So the first thing that you're going to do is you're actually going to sign up for a brand new AWS account. And in that account, you're going to enable the AWS Organizations Service. And that makes it the overall management account for your organization. You're going to create this new account because you don't want any of your existing dev or production resources actually running in it. You want it to be clean. It's there solely to manage the organization and make consolidated payments for all of the other accounts. Underneath that, using the service, you're going to create some organizational units. Now, these are ways of organizing your accounts and applying top-level policies across them. We recommend that you create one for security and another one for your workloads. And under that security OU, we're going to recommend that you have two accounts. One of them is going to be for your security tooling, and another one is going to be for your centralized logs. We're going to speak on both of those in a little bit here. Under the workloads OU, you're then going to have a couple of additional ones, one for production and one for non-production. Those are ultimately going to have different policy and access requirements. So with this structure in place, you can then go ahead and invite your existing AWS account from prototyping, and that typically goes here, under production. Now, it could also be a dev account if you haven't launched your product yet and you want to start putting this structure in place. All right, let's go ahead and remove some of those OUs from the diagram here and clean it up a little bit so we could take a closer look at identity under this structure. Now, with a single AWS account, you're creating things like IAM users to get CLI and console access. Now, if you tried to use IAM users in all of your accounts individually, it actually does become really tough to manage. You end up having multiple users representing the same person in different accounts, and keeping all of those permissions and passwords and keys in order can actually become quite difficult. And so instead, what we recommend at this stage is that you then switch over to using the IAM Identity Center, and that's going to be in your org's management account. Now, inside the Identity Center, first you're going to be creating permission sets for the different levels of access that your users are going to need into the different AWS accounts. You then create users inside of Identity Center, and those are going to be replacing the ones that you have in your original account. And then you go through the process of mapping the users and the permission sets into the individual accounts that you're going to want them to be able to access. From that point, you start instructing your users to actually log in using the Identity Center moving forward, and that way you can then actually delete the IAM users out of the original account. Now, another thing to consider at this stage is it might be the right time to actually purchase a corporate identity solution, or an IDP for identity provider, right? So in this case, you're not going to be creating the users directly inside of the Identity Center, but instead you'll be setting up a SAML integration between the IDP and the Identity Center. This lets your users actually log into the AWS with their corporate credentials through the IDP, rather than signing into AWS directly. So the main thing is to ensure that if you buy one of these, that the IDP does support the SCIM protocol. It's the protocol that allows it to synchronize with Identity Center automatically. Now, we did recently publish a guide, and it provides a walkthrough of this process of transitioning into multiple accounts. It also includes considerations for using our Control Tower service. So Control Tower, it automates creating a best practice organization, which includes setting up both the security tooling and the log archive account, as well as enabling Identity Center. So the main thing is that you do have somebody on your team that could be like the main administrator for Control Tower, understand its operations, guardrails, ensure that the overall team is able to operate within its requirements. But yeah, for a discussion on that, you can find that in this guide here. All right, so that covers environment isolation, centralized identity. Let's go ahead and talk some permissions and credential rotation. All right, as your team grows, more people are going to be involved with creating and managing access policies. So there's going to be increasing room for people to, make mistakes. So it's important to continually look at the amount of access that's actually being granted across your organization. You're going to have developers that are focused on creating policies for the workloads that they're building. You might have some DevOps people at this point where they're going to want to catch any issues with policies before they make their way out to deployment. And your security leads, whoever those might be, want to ensure that if a bad policy does make its way out, that it does get caught and fixed quickly. And so to help with these scenarios, we have the IAM Access Analyzer service. It does have the ability to generate policies for you, validate policies that you author, and also perform ongoing access analysis once they've been released to production. So taking a look at what that looks like, let's say we have a developer here, and they're working on a new workload that they create a role for. So now, rather than write the policies for that role manually, they can actually deploy the workload into a sandbox account, just a clean environment. And they give that workload then wide open permissions temporarily. You can then configure the IAM Access Analyzer to monitor that workload's role and run it through its suite of integration tests. And so when the test's then complete, the IAM Access Analyzer will generate a policy based off of the API calls that it actually observed that role making. So that way your developer doesn't have to worry about trying to handwrite all of that out or understand which API calls are actually being made. So the developer, they then check this policy into the CI/CD process. That then calls out to Access Analyzer during one of the steps of its build phase. If there's no warnings or errors, the build can then proceed. Otherwise, you have it fail, and the developer has to go back and fix those. Now, once the policy gets deployed to production, you can then set up the Access Analyzer to watch for any changes that allow external access inadvertently. Any findings that it generates, you can then have those sent to your security tooling account, and that way your security or your tech lead can help keep an eye on things and make sure that they get corrected. So in addition to access analysis, you're going to want to also periodically rotate any static credentials that you do end up having. Now, it is not a recommended practice to actually have static credentials, right? But there are still cases of third-party software or technologies like databases that sometimes don't really give you a choice. So you should always look to see if there is an alternative available. A common one is, say, integrate your CI/CD software using the OpenID Connect protocol directly into an AWS account, as opposed to having it actually provision IAM users and use key pairs, right? Otherwise, if you do end up with some static credentials, you want to rotate those at least every 90 days. So to help with this rotation, AWS did publish this solution here. It uses a few Lambda functions, and that way they'll alert you if the credentials do get old. It integrates with IAM and Secrets Manager, so it can generate a new credential for you. You then go and update your applications to use it accordingly, and once you're done, you can then have it delete the old credential when you're ready. So it is a nifty solution. It'll help keep your credentials from going stale with minimal effort. All right, now I'd like to go ahead and hand things over to Faisal, and he's going to talk about some security operations, starting with some logging and monitoring.
All right, thank you, Jay. So we're going to continue on the theme of centralization at the scaling up stage. A key practice during this stage is to have all of your workloads and AWS services configured to send their logs into a central account, the log archive account. It's going to give you one place where all of your application and audit logs are stored to make it easier to perform reporting and analysis, especially when needing to query across multiple accounts, multiple log sources. It also ensures that if there's ever any unauthorized access by somebody in one of your accounts, that person can't modify the audit or access logs to cover their tracks. So we're centralizing logs into the log archive account. How are we going to search these logs? Now, querying log files is a core capability at this stage. There are a lot of products on the market that provide this ability, but many of them can be costly and have too much overhead for a startup that is at the scaling up stage. Instead, using a combination of Athena and QuickSight in the security tooling account is a simple way to build foundational security reporting. Right? So Athena enables you to query your logs using SQL. There's no infrastructure to run, and Athena only charges by the queries you run. So keep your overhead and costs to a minimum. Here's an example of a CloudTrail logs, querying CloudTrail logs from within the security tooling account. As you can see, the UI for Athena provides you the query editor, so there's no additional tooling to install. Now, in addition to querying your log files, the security tooling account is where you will be centralizing your security findings to create a single pane of glass for your entire organization. For example, during prototyping stage, one of your recommendations is to enable Amazon Guard Duty to help with threat detection. We also recommended using IAM Access Analyzer for alerting on misconfigured permissions. Both of these services, along with many other security services, generate findings that you'll want to view in one place, rather than having to log into different accounts and services in each separately. So how do you do this? You can do this by enabling Security Hub service for your entire organization. The process is fairly simple. Within the management account, you go to the Security Hub service, and under the option to delegate admin, you enter the security tooling account ID. You then log into the security tooling account, and in the settings for Security Hub, you enable auto-enrolling for all accounts in the organization. That way, even as new accounts are created, their findings will be sent to the security tooling account automatically. For a full walkthrough of setting up Security Hub for your organization, as well as getting started with using Athena and QuickSight to query and visualize finding information, you can use this guide linked here. We also just announced here at re:Invent during Adam's keynote the preview of Security Lake, which automates the collection of your security data across AWS services and third-party partners and normalizes into a standard format to make querying and reporting easier. So it's also worth taking a look at this new service. In addition to a single pane of glass for your security findings, Security Hub can also trigger automated responses when it receives a finding. Our security specialists created this solution to deploy a number of common automated responses in a way that is extensible. So you can use this as a starting point and then build additional responses as you like. Examples include fixing open security groups to the world, ensuring EBS volumes are encrypted, and that things like snapshots and S3 buckets are not open to the public. OK, so now we have central logging and foundational reporting in place. Let's take a look at monitoring and compliance. So earlier, we described your team as being mostly generalists at this stage. You might have a couple of DevOps people, but a lot of their time is going to be spent looking at metrics and dashboards on the screens. So it can be difficult to have someone keep an eye on security findings, let alone respond to them. So that is why, at this particular stage, many startups will consider partnering up with a managed security service provider, or MSSP. This type of partner is specialized in providing 24/7 security monitoring. They'll provide the eyes on the glass to spot any unauthorized activity inside the accounts. Think about things like Log4j and the recent OpenSSL issues. It can really help to have a dedicated partner looking out for those things and advising on how best to keep your systems patched up. They can also help with data privacy concerns, detecting if sensitive data lands in unintended locations, scanning for malware, and other related privacy concerns. For a full list of AWS security competency partners, including level 1 MSSPs that are deeply familiar with operations on AWS and the unique needs of startups, recommend checking out the link on the screen. All right, let's talk about another fun topic, compliance. Who's excited? OK. So at the scaling up phase is also the time to understand and prepare for compliance. Complying with frameworks such as SOC 2 and ISO are key to unlocking potential deals with the upmarket enterprises and international customers. Regulated industries such as healthcare and financial services require adherence to HIPAA and PCI. So laying the groundwork while scaling up at this stage prevents the need for disrupting your business later on with an all-hands-on-deck approach. Now, groundwork for compliance involves identifying your target frameworks and formulating controls, engaging with a compliance partner that can conduct readiness assessment early on to avoid any surprises later, and leveraging the right AWS services to automate evidence collection and reporting. In particular, there are two key services that play a key role in compliance preparation at the scale-up stage, AWS Artifact and Config. Now, you should all be familiar with Artifact. Within Artifact, you can download security and compliance reports for AWS, such as SOC 2 and ISO, as well as review, accept, and manage online agreements with AWS, such as the Business Associate Addendum for HIPAA. The second key service at the scale-up stage is AWS Config. Now, Config is a service that continually watches for configuration changes to your resources and can evaluate them for compliance with your company's policies. Within Config, there's a feature called conformance packs that help with formulating controls and assessing your security posture against a compliance framework or an accreditation body. Now, there are a number of sample compliance packs pre-built, such as FedRAMP, PCI, and HIPAA. You can also author your own custom rules into a custom conformance pack. Now, in addition to compliance, conformance packs can be particularly compelling for startup customers for reporting on best practices adherence for the specific services you're using. Many of our startup customers like leveraging serverless services. There is a conformance pack for operational best practices for serverless, as well as other services like WAF, RDS, ECS, and so on. OK, so that completes our sections on security monitoring, reporting, and compliance preparation. I'll hand over to Jay now to talk about some key takeaways from this stage and kick off the scale-out stage.
Great. All right, so mic check. Hello. There we go. Key takeaways for this stage, it's all about building centralization, right? Centralized identities through the identity center, centralized logging with the log archive account, central security reporting off of that account using services like Athena, and also some central monitoring in the security tooling account using Security Hub. So, let's move on into that next stage.
Let's do it.
Scaling out as the dance party breaks out. At this point, you're typically going to have raised a Series B or C or some additional rounds of funding. You've had some success in that initial launch market, and now you're looking to expand into new markets. Perhaps you're moving upmarket into the enterprise space, or you're moving over into new geographic regions, or you're introducing additional products. Now, to support these efforts, you're going to have more specialized roles, such as having folks that are dedicated to site reliability, database administration, and, you guessed it, security. So overall, major focus is going to be maintaining a high bar for quality and execution as you're bringing more people on and supporting a wider base of operations. Now, you don't have the luxury of having a single central team anymore that can just own everything, right? So that's why the theme for this particular stage is going to be one of delegation. So we talked about centralization before, now we're going to talk about delegation. You need to empower your teams to remain agile while enforcing boundaries across the kinds of operations that they're going to be allowed to do. You achieve this through capturing in policy what are called your security invariants. And you're also going to be setting strong data perimeters around your resources. You'll have some new standards in place for new AWS accounts, and you want those to be deployed automatically when those accounts get created. It's also the stage where you're going to want to have a central security team with appropriate tooling in place specific to their needs, but alongside what we call a security guardian program. So we'll talk about that. A key output from your teams are going to be your incident response playbooks, and you should also be in a good place at this point to achieve compliance certifications as needed. Now, during this stage, you're going to be adding potentially a lot more AWS accounts to your organization. You're going to have more development and more production environments for your workloads, more sandbox accounts for individual engineers to continue to try new things out. And with this expansion, it becomes important to capture in policy the idea of security invariants. These are statements about your operation that are absolute at an organizational level. That way, nobody within the organization should be able to work around them. So examples of invariants are statements such as workloads can be deployed into approved regions only, or guard duty cannot be modified. You can also scope invariants at an OU level as well, such as restricting sandbox environments to specific EC2 families. Now, invariants at an org or an OU level, those are enforced using the service control policies feature of the AWS organization's service. So here's an example of one that restricts workload deployments to European regions only. Notice how it uses a combination of a deny star, but then it creates a list of exceptions using a string not equals clause. It's a very common combination of using a deny and a not condition, and that way it ensures that there is an explicit deny somewhere in that policy evaluation chain. And that way it can't be overridden with a conflicting policy that has an allow statement. It's a bit of a double negative, but it enforces the deny. Now, here's another example. It just prevents modifying out guard duty. You simply just put a deny on any destructive guard duty actions across the board. Obviously, the list there is a little bit truncated for display purposes, but you can imagine that would be the full list of modification actions. Finally, we also have a policy. It's going to only allow, say, T2 micro instances to be used in sandbox accounts. You can see how this policy, you can apply it just at the sandbox OU level, right, instead of all the way up at the workloads OU level. And it's an example of how you can have more broad invariants enforced at higher levels of your organization and then get more strict invariants enforced at the lower levels. Now, there's a lot of common service control policies in the AWS documentation, which is where I got these from. The documentation is linked there. And so that way it's easier for you as a startup. You could just kind of go in and grab the ones that you would like to apply and go ahead and apply those in account rather than trying to write them all yourself from scratch. Now, you can also use this concept of security invariants to create a data perimeter around your operations on AWS. Now here it's the idea that, let's say you have all these AWS accounts that are inside of your organization, and you only want the trusted principals from within your trusted networks to be able to access your trusted resources. What you don't want is, say, a trusted principal to be able to access your resources from outside of your accounts or network, right? Role exfiltration, trying to use keys to come back in. You want to be able to stop that. You also don't want your principals being used to access untrusted resources that are outside of your organization or your network, right? So enforcing this type of perimeter uses a combination of resource policies, VPC endpoint policies, service control policies, and also IAM role trust policies. So here, let's say we're going to use a resource policy on an S3 bucket. And this one's going to enforce that only trusted principals from within our organization are going to have access. We do this by using that principal org ID condition key. You can also use condition keys like principal org paths, which will restrict the accounts within a specific OU. You can also use principal account, and that way it'll restrict access to just one account or a list of accounts that you specify. We're also going to want to check the principal is AWS service condition key here, and that ensures that we're still able to grant AWS services permissions to access the bucket as needed as well. Obviously, those are outside of our organization. That's the one exception, right, that we want to create in this case. Now, in the case of the analyst here, that say they're assuming a role to access the bucket, we're going to have a role trust policy. And in that policy, we just put a blanket deny on anyone that's trying to assume the role from outside the organization. So this is the kind of statement that you can add to the your existing role trust policies. So you'd still have all of like your allow statements on who can assume the role, such as allowing the analyst here, but maybe not a marketing person. And then this is, the deny is putting just that extra layer on so that they can only assume the role if they're acting from within the organization boundary. Finally, blocking principals from accessing untrusted resources outside the organization, we can use a service control policy. And so here, rather than principal org ID, we're going to be using resource org ID. And that's a condition key that was released earlier this year. So in this case, it's going to be taking a look at the org ID for the principal that's trying to take the action, and it's going to be comparing that against the org ID of the resource that's being acted upon. And if those don't match, then the action ultimately is blocked. So if you would like some more details on building data perimeters, we do have a white paper on the topic. You think white paper, a little bit long, but this one's a nice one. It's quick and easy. It's a quick and easy read. So for startups, it's got some really great example policies and some additional advice to consider. So definitely recommend taking a look at that one. All right, we've covered some security invariants and some data perimeters. Now let's go ahead and talk about automating the creation of AWS accounts. Now, I mentioned earlier, you're going to be adding a lot more AWS accounts during this stage. And as you've seen through some of the examples, there can be a lot of things that you'll just want to have applied as a standard inside of any new account. Thus, if you have a way where you can create accounts and have those standards applied automatically, you can actually delegate account creation out to your individual engineering teams. So to do this, you would have your security team maybe work with some DevOps folks, or if you have SecDevOps, that's even better. They would capture all of your account standards inside of a CloudFormation template. Right? A template would include configurations for VPCs, security services like Security Hub and Guard Duty, mandatory roles and any other access controls, references to golden images, and so on. Security team's then going to use our AWS Service Catalog capability. And they publish the template in that service as a product, right? Then your engineers, they sign in through Identity Center, they go to the management account, they navigate over to the Service Catalog service, and they'll just see launching a new account there as a product with all of that automation and permissions that it needs pre-configured. And that way your individual teams actually don't need the permissions to do all the account creation operations themselves. The only permission they need is the ability to launch this product. The product itself through Service Catalog will have all of the permissions pre-configured to be able to launch it. So you can scope down permissions that way. For those of you who do use Control Tower or go down the Control Tower route, it has this capability provided out of it. It's called the Account Factory, and it looks like that. But if you're not using Control Tower, we also do have a walkthrough with some pre-built templates and some code to make standing that up actually easy for you as well. OK, with that, I'm going to hand things back over to Faisal, and he's going to be talking about building up a security team and a Guardian program.
Great. Thank you, Jay. So let's scale our humans as we're scaling out. So as part of the scaling up stage, if you remember, we recommended partnering up with a MSSP. For scaling out, a lot of that capability will start to be developed in-house by way of a central security team. As mentioned during the intro earlier, the trick is to strike the right balance between functions that require central authority versus those that can be delegated out to the individual development teams. Now, much of the topics we have discussed so far would fall under the responsibility of the central security team. Examples include managing the overall organization and account structures, corporate identity and access, authoring service control policies, and other top-level invariants, as well as leveraging the security tooling to conduct analysis and reporting for both incident response and on the overall security health of the business. On the flip side, you'll want to delegate out certain responsibilities to your development team. This includes things like authoring workload permissions, integrating static code analysis and code reviews for potential vulnerabilities in the build and deployment pipeline. There's also some software supply chain considerations, such as ensuring any third-party libraries are being vetted and are staying updated to the most current version. Your development teams will also want to make sure that they're staying up to date on the latest coding, safe coding best practices, and ensure that they're being consistently followed even as people come and go. So to support these capabilities, we recommend establishing a security guardian program. The idea is for every development team, you have one member formally recognized and embedded as the security guardian. This doesn't have to be a full-time job, but rather can be anyone on the team who has a passion for security and wants to help ensure the practices we just described are implemented and maintained properly within their dev team. The main thing is for this person to meet regularly with the security team to ensure all of the policies and practices within their team are up to date. They can also create a continuous feedback loop with the security team so that things like top-level policies, permissions can be adjusted, or any third-party software can be approved as the needs of the organization change. So as an example of this security guardian, security team collaboration, let's say your security team has a specific static code analysis tool, or SAST, they want every dev team to use. The security guardians for each team can then ensure that this tool gets included in the build and deployment pipeline. With some training, the guardians can help their teams resolve any findings that this tool generates and also provide feedback back to the security team for ongoing refinement. Now, AWS created this SaaS tool called Automated Security Helper, available as an open source project. This tool is used by both our professional services organization and by our guardians in our engineering teams. So if you're looking to get started with application security quickly, this is one option worth looking into. So with our security team and guardians in place, let's now talk about building incident response playbooks. Now, should a security incident ever happen, you'll want the ability to respond quickly with a plan already in place. To do this, you'll need to take some time to define your response procedures called playbooks. The industry standard for a well-designed playbook incorporates the following: preparation, detection and analysis, we have covered this already, containment, eradication, and recovery, and post-incident review. Let's take a look at how to build a good playbook. So a well-designed playbook will identify the following: the teams that are involved in the response, the tools that they will use, the access they will require, and the steps that they will follow, more importantly. So as part of your preparation, you'll want to ensure things like the tools you identify here and the permissions that the team needs are all readily available. For example, if the team needs to use the AWS CLI to assume an IAM role that has permissions to update policies, it can help to have that CLI and the IAM role in place ahead of time or easily deployable. That's going to be critical to having an effective response. Okay. In addition to the preparatory information, the playbook contains all the step-by-step actions that the team will take in response to the issue being addressed. It's important to be detailed in these steps. You want to think about every individual action and not leave any gaps. As you can see on the screen, it helps to indicate the type of response category for each step as well, as different teams are usually responsible for the different kinds of steps. Okay. So finally, it helps to have an example of how each step is performed at the bottom of the playbook. For example, let's say we are creating a playbook for exposed IAM credentials. One of the analysis steps is to identify the account that owns the exposed credential. In the playbook, you would want to include example command that calls out the STS using the CLI to pull this information. Now, for a full example of the playbook we were just showing, you can find it at the first link on the screen. For a full discussion on comprehensive incident response plan with further guidance, recommend the white paper on the second link on the screen. Okay, we'll now move to the last topic of the scaling out posture, compliance certification. Compliance is back. All right. So as you recall, during scaling up, we talked about identifying your target frameworks and control objectives, and using AWS Artifact to download the appropriate reports and agreements. We also talked about formulating controls by using AWS config conformance packs. At the scale out stage is where we usually see customers needing to attest to and achieve their compliance certification. To help with this specific effort, AWS provides the Audit Manager service. So let's talk about that. Historically, evidence gathering for compliance was a very manual and point-in-time process. It often involved capturing screenshots and manually inputting evidence into Excel, and then hoping that the auditor agrees with what you collected. Audit Manager, on the other hand, continually sources evidence directly from the services such as Security Hub, Config, CloudTrail, as well as invoking specific service API calls from the services that you configure. You can also upload manual evidence into Audit Manager. So from this data, the Audit Manager generates an assessment report based off of the compliance framework that you specify. For example, if you target SOC 2, Audit Manager will automatically map and select the data sources and services in scope for SOC 2. This is going to greatly reduce the overall engineering effort of evidence collection and reporting. And more importantly, it ensures that the data you're reporting off of is timely and not stale. The AWS Compliance Solutions Guide available at this link provides the collateral to help you with your compliance journey. It includes samples for completing security questionnaires, helpful links for finding the AWS services that are in scope for a particular compliance framework, and individual pages for frameworks like PCI, HIPAA, or GDPR that include targeted quick starts and guides. So it's your one-stop shop for compliance. That's it for compliance certification. Hand it back to Jay for some key takeaways and on to sustaining.
Alrighty, so key takeaways from this stage is that you're all about enabling delegation. You're enabling your teams to be more independent, to be able to own the workloads and permissions, but with the condition that they adhere to your boundaries. You have a central team that is responsible for setting the boundaries, but you also have guardians on every team that helps to create a feedback loop. And so that collaboration is going to allow you to be able to capture how you work together should any security incidents occur, and also work together on your compliance certifications. So with that, we've now reached the final stage, which is sustaining. Now at this stage, well, you're pretty much not a startup anymore, right? Organizationally, you look like an enterprise. So all the things that work really well for your business, they've been captured in standards and policy, and those ensure that you continue to run smoothly even as people come and go. It's not uncommon by this stage to have some diversification through multiple products, services, operating across multiple markets, and so on. Now, the theme for this stage is going to be one that is continual refinement. There is a whole world of these enterprise levels kind of security practices out there that your company is going to be in a good position to be able to evaluate at this stage. So, for the sake of our talk here today, rather than try to delve into that whole like enterprise security realm in detail, what we're going to do is actually just focus on a few key topics here that are refinements, right, of some of the earlier techniques that we discussed. So we'll start by sharing a way that you can further refine your permission delegation. And then we're going to also talk about ways that your security team can test its incident response playbooks and introduce the practice of threat hunting. As a bonus, I'll then also talk a little bit about zero trust. It's quickly becoming a new standard for cybersecurity. All right, so earlier in the earlier stage, we looked at how security invariants and data perimeters can help with putting boundaries around what permissions can be granted inside of your organization. It helps to start building that confidence that you can actually delegate permission management out to your individual teams rather than having it all done by one central team. However, both the service control policies and resource policies, they can still be fairly broad stroke in certain situations. Sometimes you need to have just like a little bit more granular control over what your permissions that your teams are going to be allowed to grant. So, for example, let's say that we have decided to launch our workload in Germany, where there are some strict data residency laws. And we want to ensure that this workload can only be deployed to the Frankfurt region. Now, we have a couple of engineering teams that are working on it, but each team has a different scope of permissions that we're going to want to be able to have them grant to their workloads. So it can't just be done with a singular service control policy very easily. So to top it off, let's say it also needs to stay governed by the policies of our non-production OU in this case. Now, to achieve this, we're going to use a special policy document that is called an IAM permission boundary. Now, it looks like a permissions policy, but rather than granting permissions, we're instead going to be defining the maximum scope or the boundary of permissions that we're going to be allowing someone else to then be able to grant to their principals. So in this example, let's say we have a security admin, and they're going to want to allow the engineering teams to create their own permission policy, and it's going to be then granting some DynamoDB operations. But we want to ensure it's only the put, update, and delete actions for tables that are in the Frankfurt region. So like that's the boundary that we want them to be able to grant. Put, update, and delete in the Frankfurt region. Now, security admin is then going to go and create a special IAM role in the Frankfurt account that the engineering teams can then assume. That role is going to allow those teams to create their own IAM roles as needed. However, they're only going to be allowed to create those roles if they attach the Frankfurt permission boundary to it that we had created in the previous step. So when the security guardian on the engineering team then goes to create the IAM role with a CLI or the SDK or CloudFormation, they're going to have to set this permissions boundary attribute, or that create role command is going to fail. Now, after they've created that role, they can then go and attach a permission policy to it. And in that policy, they can specify really anything they want, right? Here, they're trying to say, like, let's just go ahead and allow all DynamoDB actions against a user's table in Frankfurt. Now, however, because this role has the permission boundary attached to it, the actual permissions end up only being the put, update, and delete actions. So you can think of like the star in that top policy. It's not really referring to all actions in this case, but rather the list of actions that are spelled out in the permissions boundary document. Now, likewise, if the permission policy tried to allow these actions but to a user's table in, say, like the Oregon region, as opposed to Frankfurt, the role is actually going to end up not having any permissions at all, right? Because the permission boundary, it requires actions to be scoped to the Frankfurt region only. So with this technique, you can see how you can like really carve out some fine-grained boundaries, even within specific accounts, for what permissions your teams are then able to grant their workloads. There is a fuller walkthrough of this example and some more detailed description on how delegation with permission boundaries works in this blog post linked here. Great. OK, let's move back on over to Faisal, and he's going to talk about refining some of your security operations.
Great. Thank you, Jay. I saw a couple of folks wanting to capture QR codes. If you missed any that you wanted to, we'll exchange emails after the talk, and we can share the deck with you. All right, so a quick recap. At the scale-out stage, we distributed security ownership by embedding the guardians in every team. We also created incident response playbooks to equip the security team and guardians to investigate and respond to the potential security events. At the sustaining stage, you'll want to test your incident response capability, not only from an operational perspective, but also from an overall organizational perspective. For example, to test the operations of your playbook and the responsibilities of the individual teams, you can simulate an event in a test environment and practice executing the steps and commands listed in the playbook. From an overall organizational perspective, we recommend running tabletop exercises which go beyond the scope of the security team and include other business teams like legal, PR, potentially your executive suite. The purpose of this exercise is to test communication effectiveness so that your business is prepared for any situation that potentially requires regulatory reporting or other external communication. Now, for both of these exercises, it can help to have a third party conduct them for you to mitigate any biases that could otherwise influence the results of the testing. Now, another key practice at the sustaining stage is to establish threat hunting. This is a process of following up on indicators of compromise, or IOCs, that are surfaced from threat intel sources, internal detection tools, end user reports to determine if the indicator is a real threat. Imagine walking into work and the CEO wanting to know, I got a suspicious email, what are you going to do from then on? So for example, let's say you observed increased API calls from one of your application endpoints, and it is unclear if this traffic is real, which is a good thing, or from somebody probing for misconfigurations, which is a bad thing. Your security guardians can use this indicator to query request logs. Remember, we have this capability with Athena to see if this is good traffic or if there's anything suspicious about it. If they do find that the traffic is suspicious, they can report their findings to security team, who can then execute the appropriate incident response playbook. So the overall idea here is to leverage your security team and guardians to develop a comprehensive incident response playbook, test your overall readiness to execute those playbooks, and conduct threat hunting based off of the indicators of compromise to determine if those playbooks needs to be executed. All right, back to Jay to finish the prezzo after some discussion, as promised, on Zero Trust.
All right. So Zero Trust, it's becoming the new standard for cybersecurity, and it's actually becoming mandated in certain regulated environments. Now, before Zero Trust, we'll talk about like what exactly is it, right? It was common to establish this like hardened network perimeter around your internal private resources, and you would then refer to anything that was within that network as the trusted zone, right? So any traffic then that was coming from the public internet or from other outside sources was considered the untrusted zone, right? So there's like a little bit of an implicit trust that is there, that if you're on my network, then you're somebody that I sort of implicitly trust, right? And so while you would still have identity and authorization within the trusted zone, perhaps it wasn't as applied quite as rigorously. And so sometimes you would have end users having like blanket access to internal applications, services that are able to call each other maybe without some explicit authorization, maybe some similar loose access controls to databases, and general lateral visibility across the network. Now, on the other hand, if you were to host a public endpoint, such as a website, and that required any kind of access to your internal resources like a database, well, boy, I mean, you would layer in all kinds of scrutiny, right, to ensure that that traffic was fully authorized. You would have strong identity, authentication, and authorization for every single request, auditing of every action, access rules that block traffic based off of known bad actor signatures, and maybe some intelligence around baseline versus anomalous behavior. So under the Zero Trust model, the idea of that trusted zone versus untrusted zone goes away. All traffic, regardless of network, is considered untrusted, hence the name Zero Trust. Now, you could still use network-centric controls to create that sort of perimeter, but they've just become one part of the overall trust decision. So instead, the idea is that you're going to apply those same rigorous practices from your public endpoints to all of your internal resources as well. So for your internal users and services, this takes the shape of every actor having a strong identity, every single request being authenticated and authorized, and also creating small segments of the network around your workload components, so that way you can create fine-grained traffic flows between them instead of having general lateral visibility. And when you read through that list of Zero Trust characteristics, you actually see the AWS services, they really adhere to them, right? The security of our APIs is not dependent on network reachability. They can all be accessed through public routes. Requests get made over TLS encrypted channels, and they require your access keys to be signed using SigV4. The permissions are verified for every single request. And even AWS services themselves, they have their own identity that you need to be able to authorize their access to your resources and other AWS services, and that's done by way of the service-linked roles. So all of these API requests, whether they're made by humans, your workloads, or AWS services, they're all auditable using CloudTrail. And now certain AWS services also provide you ways that you can establish Zero Trust within your own workloads. You can use the API Gateway service for internal endpoints as well as public, and it integrates in with IAM for identity and authorization. You can integrate your application load balancers with an OIDC-capable identity provider, and that will provide authentication for your internal web resources. We just announced the preview of Amazon Verified Access, which actually simplifies that whole process as well. So that's in preview today. VPCs support very fine-grained microsegmentation with strict traffic routing rules by way of its subnets, security groups, and different types of gateways. And we also launched the preview of the VPC Lattice service, which helps in this case as well. Many AWS services support VPC endpoints. It not only ensures that traffic remains private when calling out to AWS services, but it also allows you to layer in additional access policies. So, to ensure that your security posture remains sustainable over the long run, it helps to build in these Zero Trust principles early and often. So as you're building your workloads, consider are you solely relying on the VPC to establish trust? If you are, think about how you can provide strong identity to every actor in the system, how you can verify and authorize every request that's being made. Leverage AWS capabilities like these wherever possible. It reduces your overhead. And also be proactive about keeping an eye out for new services like the ones that I just mentioned, and features that also contribute to Zero Trust, both by us and our partner vendors, as that landscape does continue to mature and become simpler over time. So, we made it through to the end of our talk here today on evolving your security through key growth stages. We talked about establishing a baseline during your prototyping stage, centralizing your identity logging and security reporting in the scaling up stage, enabling delegation and collaboration during the scaling out stage, but doing so with appropriate boundaries in place. And then also some ways you can continually refine your posture as your business sustains its growth. Across each of these stages, we've also touched upon how you can build with an eye towards compliance and Zero Trust as you go. So thank you very much for attending. We hope that you enjoyed the session today. We'd really love your feedback. If there's anything that you found helpful or if there's anything that you would like to see improved, please do fill out that session survey. Let us know. Our contact information is also up there if you'd like to reach out and speak further about any of these topics. Also encourage you all to check out the Startup Loft over in the Expo Hall. They'll also be able to help direct you to your account team or a solution architect if you'd like to have a more direct discussion about your security on AWS. If you want to come up and ask questions, we are at time now. So thank you very much for attending, and we hope that you enjoyed it.